Good morning, students. How old are you? Yes, very good. I'm also very fine. It's been long since we have met, right? Because of coronavirus, we were having online classes, and I'm very sure that you are all eagerly waiting for this day. Okay, have you all missed our school? Yes, I'm very happy to hear that. I have also missed all of you. Okay, so we have entered to a new chapter 4. Am I right? Yes. And what was the topic we have learned last? It was about types of forces. So today we are going to a new topic. Before getting into that topic, let me tell you a story. Just listen to that story and I will ask you a questions based on that story. Okay, this is the story. Mindu is a child like you, and her father presented her a ball on her birthday. One day she was playing with that ball and she noticed that when she rolled this ball on the ground, it stopped by itself after some time. She wondered what happened to the ball, because no one is there to make an obstacle or no one tried to stop that ball. The ball gets stopped by itself. How does it happen? She was totally confused and tried this many times. She rolled the ball and again it stopped. She again repeated this experiment. But she found that all the time the ball gets stopped. Actually, she was very sad because she is not getting the reason for it. So I'm very sure that you all are very brilliant and you all can help Mindu by giving her answer for her confusion. Okay, can anyone tell what will be the reason for the stopping of the ball? Okay, so you also have a confusion, right? Then after the end of today's class, I am very sure that you all will be able to give me the answer. And let me ask you another question. Why do we slip when we step into a banana peel? You all have experienced this, right? Yes. What may be the reason? Or why do we slip when we walk through a smooth or very slippery surface? What is the reason for all this? Okay, today we are going to find out answer for all our questions. So, let's begin our class by doing an activity. So, for doing our activity, we need a book. Either your textbook, notebook or any book. So, I place this book on this table. When I do this activity, you should carefully observe the direction of the book as well as the force applied. So in the last class we learned about force. Hope you all remember it. Okay, good. So just observe the direction of the book as well as the force applied. So I have kept this book on the table, and what I am going to do is that I am going to push this book towards my right side. And you have seen that the book stopped within a few seconds, isn't it? And now I am going to push this book towards my left side. You have seen that it stopped after a few seconds. I have told you, you should observe the direction of the force applied as well as the direction of the book. When I apply force from my left side, see the direction of the book, as well as when I applied a force from my right side, just see to where the book has moved. Okay, so this is our activity. I think you all have watched it. Okay, you all have understood it. Hope you don't have any doubts. Am I clear? Do you have any doubts? Okay, good. If anyone want to check the table, in order to find out the texture of the table, you can come and just touch the table and understand its texture. Okay, so you all understood. Then we can move to the discussion. So we have 4 groups, right, in our class. and I will be giving you some questions and you should discuss these questions in the group and find out answers and you should present it. So these are the questions for you. Okay, so have you all discussed? Yes. Then give me the answer. What was the first question? What might have stopped the ball? What might have stopped the ball? Yes, very good. It is the table, because there is nobody around the table, around the book, as well as nobody is applying any force to stop the book, right? So maybe table is the reason for the stopping of the book. Okay, done. What is the next question? What is the texture of the table? Is it smooth or rough? Yes, you all have touched the table and you found that it has a rough texture. Okay, good. That answer is also correct. And what about the third question? What was the third question? Okay, then tell me what exactly have stopped the ball? By seeing the previous two questions, you told me that table is the reason for stopping the book, and you told me table has a rough texture. And by connecting two, can you tell me what exactly have stopped the ball? Yes, it is because of the roughness of the table. Very good, your answer is correct. And then tell me next question. Such a force that opposes the relative motion of bodies is known as, what can we call? Which group knows that answer? Okay, very good. Friction. Such a force that opposes this relative motion is known as frictional force. Okay, very good. Then what about the next question? Yes, what was it? Okay, define frictional force. Who can define frictional force? Which group can? Okay, group number 2. Tell me the answer. A force that opposes the relative motion is known as frictional force. Okay, correct. It's correct. What is the next question? Yes, when you apply force along the right, friction acts along dash direction. Which direction? Yes, force was applying along the right direction, so friction acts in the left direction. When we define frictional force, we say that it opposes the relative motion. So the motion is along right direction, so the frictional force will be acting along left direction. Okay, what is the final question? When you apply force along the left, friction acts along dash direction. What is the answer? Okay, very good, right. Hope you all understand. Okay, is there any doubt in the discussion team? So, have you all enjoyed the activity? Yes, very good. So, what can we say about frictional force? When a body moves or tends to move on the surface of another body, a force is experienced parallel to the surface, which opposes the relative motion between them. This is known as friction. And the frictional force always opposes the applied force. So you can note it down. What is a frictional force? Please note it down. So we studied what is frictional force. Now we are going to do another activity. And after doing this activity, we will understand whether frictional force depends on the nature of the surface. So let's do this activity. So I have brought necessary items for our second activity. Here I have set up an inclined plane, and I have a pencil, and I have a scale. So what I am going to do is that let the tip of this plane be point A, and I will be placing this pencil at this tip of the plane, and I am going to release this pencil. When I am releasing, you should observe the motion of the pencil as well as the distance travelled by the pencil. Yeah, I will measure it and I will tell you the distance. You should note it down. Okay. So I am placing this pencil at the tip of the plane, that is point A, and I am releasing this pencil. Okay. See, you can see that the pencil traveled a distance more than this length of the table. Am I right? This pencil has covered at least more than the length of the table. Let it be, you can note it down as 49 centimeter. We can write the distance as 49 centimeter. Now what we are going to do is that I am going to spread a cloth over this table. Okay? Carefully observe it. So I have spread a cloth, and when you spread a cloth, make sure that there are no wrinkles. And we are repeating the experiment. I have placed this pencil at the tip of the plane and I am releasing it. See? Pencil stopped at this point, and I will tell you the distance traveled by it is some 7 centimeter. So, do you understand the activity? Have you noted down the distance traveled by the pencil? Okay, very good. So, let's go to our discussion. So, be in groups and I will be giving you the discussion tip now. So, have you completed? Okay, then give me the answers. What was the first question? Distance travelled by the pencil in the first case. What was the distance? Yes, very good. It was 49 centimeter. Okay. Then, what is the next question? Distance taken by the pencil in the second case. When we spread the cloth, what was the distance? Yes, it was only 7 centimeter. Okay. In which case the distance is more? Yeah, very simple. It was in the first case. Okay, you all have answered correctly. Does the distance covered depends on the nature of the surface? What do you say? Does the distance covered depends on the nature of the surface it moves? Yes. Before spreading the cloth, the pencil covered a distance of 49 centimeter. Am I right? And when we spread the cloth, it only travelled a distance of 7 centimeter. So, could the smoothness of the surface also affect the distance? Or could the smoothness of the surface affect the distance travelled by the pencil? Yes, very good. The smoothness of the surface actually affect the distance travelled. Actually, when we spread the cloth, the roughness increases, and that's why the pencil only travelled a distance of 7 centimeter. Very good. You all have answered for that question. And why is the distance covered by the pencil is different in the two cases? We already have given the answer for that question. What is the reason? Yeah, give me your answer relating to friction. Yes, very good. Friction depends on the nature of the surface. That's why the distance travelled by the pencil in the two cases are different. So, what can we say from this activity? Yes, friction depends on the nature of the surface. And even though the surface is very smooth, it has minute irregularities. So what will be the case with the rough surface? The irregularities will be very high. So in a rough surface, there are large number of irregularities. So the force of friction will be very high. I will show you an image of this irregularity in a surface. Please observe the image. Okay, so do you understand? Yes. What all have we learned today? Do you have any doubts in it? Okay. So everything is fine. Then let me ask you one thing. How Mintu is waiting for your answer. What may be the reason for the stopping of the ball? Yes, it is because of the friction. The surface and the ball is in contact and a frictional force acts on it, and that's why the ball gets stopped after some time. Very good. What was our second question? Why do we step? Why do we slip when we step into a banana peel? Yes, very good. Why do we slip? It's because on the surface of the banana peel, friction is very less. That means its surface is very smooth. In a smooth surface, irregularity is very less. That's why we slip. And what was the other one? The same reason for the smooth or slippery surface. The friction is very less. That's why we fall. So can we say that friction has both advantage and disadvantage? Yes. So note down today's question. Follow-up activity. Please note it down and we will discuss it in the next class. What do you mean by frictional force? And force of friction depends on dash of the surface. And there is an activity assignment 2. Write it down. Organize, carry and form inferences of an experiment to prove that frictional force exerted by different surfaces are different. You all have watched the activity that we have done today. Based on activity, please elaborate this activity with more surfaces. So, hope you all understand today's class. Am I clear? Do you have any doubts? Okay, no. Very good. Then let me wind it. And see you in the next class. Thank you and have a nice day.